Hello, and welcome to the BMC Quick Course series. My name is Ken Zolkowski, and I'm a lead product developer based in San Jose, California. Total Object Manager, or TOM, ensures the availability of objects such as started tasks and USS processes which run in your z/OS system. All you need to do is define the object in an object definition base, and TOM will make sure the object is available based on the criteria you have set. There are times, however, when you will need capabilities that are unique to your site and are not available in TOM. In this course, I'll explain how you can create custom automation. When you need automation that is not available in TOM or is unique to your site, you can create custom automation by using a MainView auto operator rule or exec. The TOM API provides the TOM EXEC command. By using the TOM EXEC command, you can employ TOM services in an auto operator exec. We recommend that you use the TOM EXEC command to request functions like stop, reset, bounce, and so on. API calls have several advantages over console commands. Functions requested from within an exec can return feedback. You should examine feedback from a requested service so you will know if the request executed as expected. You can find feedback from a TOM API function in the TOM RC local variable. Another advantage of avoiding console commands is that operator console commands could arrive so quickly that they could be rejected by the system with the message, command rejected, task busy. Using the API maintains the appropriate amount of command serialization and feedback between the calling exec and the requested TOM function. If you use a console command, you won't receive feedback unless you specifically coded the exec to wait for a response from a command. The exec would have to review the messages that are issued in response to the command. Execs that are not coded to wait for the command to complete and to review the response or return code can cause unpredictable problems. If the exec was being used as a pre-start or pre-stop command, it could send back incorrect feedback to TOM, and the object start or stop command could be issued too soon or incorrectly. Here is a simple example of coding an exec correctly. In this example, we will issue a reset function against an object using the TOM EXEC command. Execs can be as simple or as complex as needed. Notice that we can perform work in a serialized manner. The TOM EXEC command requests that we reset the object named in the input parameters. After the command is issued, we wait for the feedback from the request. We can then easily inspect that feedback residing in the TOM RC variable. Feedback is different depending upon the function requested. To get details about the meaning of the feedback, see the API chapter in the TOM user guide. Depending upon the feedback in the TOM RC variable, we can take any action the author of the exec chooses. An exec such as this could call other execs, issue messages to the user, request and wait for input from the user, read information from other files, and write information to a variety of sources, and so on. When this exec is complete, we can set feedback information and pass that back to the caller of this exec. Here is an example of an incorrect exec. Instead of using the TOM EXEC command to request a reset, we used an IMF exec command to issue a console command to reset the object. Using IMF exec command in this instance would not return the needed feedback. If you supplied the name of an object that doesn't exist in the active definition base, you would get an object name not defined request rejected message in the TOM job log. You would not get feedback telling you that the object did not exist. For the exec to be aware of any feedback, you must code the exec to wait for the messages and review them. The exec must also know the difference between a message that contained a normal response and one that did not. This could be a complex process, but it is necessary to ensure that the serialization of activity is maintained and that we had received the expected feedback from the request before continuing. If you had used TOM EXEC function reset instead of a console command and the request was unsuccessful, you would get a feedback code of 8. The exec would know that the request was unsuccessful. You could then take steps to handle the unsuccessful request. You could end up using a much simpler exec that did not need knowledge of the significance of one message versus another. Using the TOM EXEC command instead of the IMF exec command statement achieves the same goal but with fewer lines of code. This not only reduces the complexity of the exec, but also increases the easy ability to obtain request feedback. Fewer lines of code also makes the exec easy to maintain. You can request a function with the console command if you don't need feedback or if the exec was not a pre-start or a pre-stop command. In such a case, the actions of the exec and the requested function do not have to be in sync with other activity taking place in TOM for the object. After issuing a TOM EXEC function statement, always check the local variable TOM RC for a return code of 144, which indicates that the CAS is down. If the CAS is down, you can't issue a TOM EXEC command. Instead, the exec must use the IMF exec command statement and check the responses from the command to ensure that the TOM function has completed and was successful. Thank you for your time. For more information on any BMC mainframe product, please visit the URL shown here.